Hello, friends. This is Seher from EasyPeasy, and today we are going to talk about Dalton's atomic theory. Now, this theory is not started from Dalton. Rather, it started way back nearly 2,000 years before Dalton in 460 to 370 BCE. In that time, a Greek philosopher named as Democritus gave us the idea about atoms. What he was thinking is that if we take anything and then cut it into small pieces, then eventually we will reach to a stage where that particle will no longer divide. And he called that particle atomos. That means indivisible. After that, he also see different types of things in this world. Some are soft, some are hard, some are solid, some are liquid. So he reasoned that if matter are made up of tiny particles, then these particles must not be all the same. He suggested that atoms differ in size and shape, and that these differences causes substance to have different properties. He also get the idea about the particles moving inside the matter, because he was observing the changes everywhere. The season change, the people, animals, plants grow, so the environment is constantly changing. That's why he also argued that atom must move, because change and motion are observed everywhere. To allow this movement, he proposed the existence of empty space between atoms. Without empty space, atoms would be unable to move or rearrange, and change into matter would be impossible. But Democritus was a philosopher. He was not a scientist, so nobody take his logical points logically. So after 2,000 years, around 1800, John Dalton was the first person who brought back Democritus' ancient idea about atoms. He was working on compressing different type of gases and checking their pressures, and then he gets some idea about atoms. He inferred that gases must consist of tiny individual particles that are in constant motion. That's how we reached to the Dalton's atomic theory that we have. Now, Dalton's atomic theory have 4 postulates. The first postulate is that Dalton, just like Democritus, also believed that substances are made up of atoms, and atoms are the smallest particle of matter. Here you can see we have a pencil, and just on the top of the nib we have carbon here. If we look closely to the tiniest part, we can see a lot of atoms present there. By looking at this picture, one thing is clear. That is the difference between element and atom. So the difference is that all these circles are representing the same element, that is carbon. And one individual circle is representing the atom. So by looking at this picture, how many elements do we have? Yep, that's right. We have only one element. And how many atoms we have? Yep, we can't count them because there are so many. Just this little part is showing so many circles here. So if we are going to take an idea about the whole nib, then we can only say that it have many atoms in it. Okay, the second postulate for Dalton's atomic theory is atoms cannot be divided into simple particles. They can neither be created nor destroyed. It is similar to the concept of law of conservation of mass. The mass of the system is same before and after the reaction, and the number and type of atoms does not change. Just like here, we have acid and base that is converting themselves into water and salt, but if you can see that they are just rearranging their places, and overall the number of atoms does not change in this reaction. Okay, the third postulate of Dalton's atomic theory is that all atoms of the same element are alike and have same masses, and atoms of different elements are different and have different masses. In this picture, you can see we have 3 different elements. The carbon is represented by gray circle, the oxygen is represented by blue circle, and chlorine is represented by green circle. If we are going to compare one oxygen atom with the other oxygen atom, they are same, they are alike because they belong to the same element. But if we are going to compare the chlorine atom with oxygen atom, obviously the chlorine atom is bigger than oxygen and they have different properties. So different atoms for different elements. And fourth, that is the last postulate of Dalton's atomic theory, is atoms join together to form compounds. And given compound always consists of same kind of atoms in same proportions. Atoms of different elements combine in a simple whole number ratio to form compounds. Now this is a very good picture showing the proportion. First, we took 2 atoms of hydrogen that is going to react with 1 atom of oxygen and they will create 1 unit of water. But if we take 4 atoms of hydrogen and let them react with 4 atoms of oxygen, again they will make 2 units of water and 2 atoms of oxygen will be left over. If we are going to change the proportion again, and this time we will take 6 atoms of hydrogen that's going to react with 2 atoms of oxygen, again they will make 2 units of water and 2 atoms of hydrogen will be left over. Now this Dalton atomic theory doesn't become a law because there have some time of limitations in his theory. And let's talk about those limitations now. So the scientific community has broadly accepted the Dalton's atomic theory except for 3 changes. The first limitation is an atom can be further subdivided into protons, neutrons, and electrons. Just like here, this is a helium atom. And now we know due to the modern techniques that the atom do have all these subatomic particles inside. So these blue circles are representing electrons, the red circles are representing protons, and the white circles are representing the neutrons here. Now, what this 4 and 2 number means here, the 4 is the atomic mass, and that is basically the addition of neutrons with the number of protons. And atomic number is at the bottom, that is only representing the number of protons in the atom. So in the case of helium, we have 2 protons, so the atomic number is 2. And we have 2 neutrons with 2 protons, that is 2 plus 2 is 4. That's why the atomic mass of helium is 4. The second limitation of Dalton's atomic theory is that atoms of same element are not identical in mass, just like in isotopes. Now here we have 3 atoms of hydrogen, but they are different isotopes of hydrogen. Here we have no neutron, here we have 1 neutron, and here we have 2 neutrons. So they don't have the same mass number now, but they all belong to the element that is hydrogen. The third and last limitation of Dalton's atomic theory is in nuclear fission and fusion techniques, we create or destroy atoms by changing them into other atoms. Just like you can see in this picture, the bigger atoms are converting into smaller atoms in uranium chain reaction. Now in the end, let's go for 5 easy peasy practice questions. Okay, who proposed the modern atomic theory? That's right, it's John Dalton. According to Dalton, matter is made up of atoms. Which statement is part of Dalton's atomic theory? All atoms of same element are identical. Dalton believed atoms were solid and indivisible. When compounds form, atoms combine in simple whole number ratio. That's it for now. Thank you very much for watching this video. See you next time. Bye for now.